Welcome back, MEFB 2132013 Manufacturing Processes class. Today we're going to talk about quality systems, quality system and process improvement. So all this while we were talking about the different manufacturing processes, be it sand casting, die casting, hot working, cold working, hot chamber die casting, cold chamber casting, metal cutting, welding, press working, modern machining. So we did so many manufacturing processes. So now we're going to focus on the industry itself. Okay, so for you to actually conduct this manufacturing processes, you need to work in an industry. You need a company, you need the factories to produce your products. Yeah, so you cannot randomly produce products as you like. All your products, your final work piece have to undergo a quality check. So in order for you to make sure that dimensionally and finishing quality is good. So how do you define the term good? In your opinion, it may be good, but in the customer's opinion, it may be bad. So in order for you to maintain the quality, you need to have a quality check or a quality maintenance. Yeah, and for that you need to follow a standard. So when you are closely following a quality standard, therefore you can assure that your final product is good in terms of quality. So if you look at around you, yeah, we have several quality systems. You have the ISO 9000 quality, ISO 17025 compliance, the ISO 9001. There's so many quality certification around you, so you need to pick the best that it suits the your industry that you're associated with. Yeah, so if you see, the main goal of the manufacturing enterprise is to provide a product with the best quality at a lower price with the lowest operating cost. So if you remember economical production way back in unit 1, yeah, a manufacturer will try to produce a product that has the best quality at the lowest price, lowest operating cost, and aesthetic in design. Is it possible? It's difficult because you always end up having a compromise, right? So to accomplish this goal, two quality management systems are used. Okay, so one is the prevention system and one is the detection system. So in any manufacturing processes, yeah, you'll have two quality check. First is the prevention system, second is the detection system. Prevention system is you detect the dimensional accuracy of the product. So you can either do it automated, okay, where you have machines to monitor the dimensional accuracy of the part while you are while production is on, or you can do it manually using a statistical process control chart. So remember that term, yeah, statistical process control chart. I will show you how it works later. So statistical process control chart is to monitor um, is to monitor hang on, okay, this is a control chart. Yeah, so statistical process control chart is to monitor the performance of your product in terms of dimension. So for example, this is for defects, but say if you are monitoring dimension, so this axis will be dimension. So say your diameter has to be 20, so you have your control limit, and your control limit is going to be 20. You're going to give it tolerance. So as long as your product falls in the tolerance of plus minus 0.05, meaning that your dimension of the product or diameter of product can fall anything between 20 minus 0.05, so 19.95, and 20 plus 0.05, 20.05. So as long as your product diameter falls between 19.95 and 20.05, you are satisfied with the outcome of the product, and the product can be proceeded for further work. Yeah, but unfortunately, if the product dimension falls out of this, UCL stands for upper control limit and LCL forms for lower control limit. So if the dimension falls outside this upper control limit and lower control limit, so instead of 20.05, suddenly your dimension becomes 20.1, okay, or 20.2, then you know that the dimension is out of control, and you can immediately reject that particular the product. Okay, so that is to do it manually. But now with automation in place, the dimensional inaccuracy can be detected on the spot immediately by machines. Yeah, so a lot of industries actually use that technique. So going back to what we're doing, so that is your prevention system. So as I told you, you can use either SPC, a statistical process capability studies, or tool analysis in order to detect that. Then number two, you have a detection system. Detection system is inspection, testing of parts, and reliability study. So once it has gone through the the dimensional check, dimensionally is good, then you are safe. So you go to the next one, which is detection system. So detection system is when you inspect test of parts and the reliability studies, meaning that you're going to inspect the surface finish of that part. So now before the product goes out, you need to give it a good surface finish. Yeah, so the surface finishing has to be in good quality or in good standards. Yeah, if you're coating it, for example, you're doing a finishing process, you coat the object, you must make sure the coating is sustainable. It will not peel off. The thickness or the density of the coating is even all throughout. So that is the second part of the check. So once the product has gone through both the checks, prevention system and detection system, then and has passed both the prevention and detection system, then your product is ready to reach out to the customers. Okay, so how do you actually maintain quality? Yeah, so performing the goals to achieve quality also demands proper documentation of quality system. So you can either choose you can if you choose, you just need to have a guide to follow. Okay, you need to use either an ISO 9000, ISO 17025, but whichever system that you use, you need to apply to that body that conducts it. So for example, ISO 17025 is monitored by Jabatan Standards Malaysia. So you apply to them formally that you want your work to be ISO certified, so you know that the quality of the work is maintained. So ISO 17025 is compliance to process. Yeah, compliance of process. So if you are running labs, that provide services, labs that provide services, like currently Uniten has a scanning electron microscopy lab that is ISO 17025 certified. So when you say it's ISO 17025 certified, meaning that the lab is following the procedure in obtaining accurate results, meaning that the machines have been calibrated and the lab personnel have undergone training to give you the best results. Yeah? And all this have to be documented and monitored. There is so much of paperwork involved in documenting the processes, the products, the feedback, customer feedbacks, complaints. Yeah, and then you have the Jabatan Standards Malaysia who would send examiners every once a year to ensure that the quality is maintained, and if everything is in place, they will recertify you for another year, and it goes on and on. Yeah, and obviously it comes with some charges as well. So this is the levels that you have to go through. So you have a quality manual of the company. You need to outline the operating procedures of each department, like who does what, where, when, how, and then you must definitely come up with work instructions. How do you operate machine A step by step? How do you operate equipment B step by step? You need to have proper clear work instructions that is ISO certified, and then you must maintain all your records, meaning that your production, if your machine is calibrated according to ISO, you must show the data of everyday performance of the machine, and show that the dimensions and the products are in compliance with minimal rejects. So you need to keep data of your production every day for the next 1 year, for the next maybe 6 months, and then you recalibrate it, and then you maintain your data, and you show that after being ISO 9000 certified, your product is complying to that certification, and it is maintaining the quality during the quality of the product is maintained during production. So all this comes under the records, yeah, under records or data supporting process activity. So what is quality? Quality is defined as the act to provide customers with products and services that consistently meet their needs and expectations. So keyword that you see here is consistently, yeah. So when you say consistently, means that there is minimal process variation, machining time is the same, product specification is the same, product performance is always the same. What is continuous quality improvement? Is the systematic method of improving processes to better meet customer needs and expectations. So there is there is something called Dr. Deming's philosophy for continuous improvement. So whether it's production or whether it's even in your own life, you must always try to maintain continuous improvement. Yeah, you don't like just stagnant, keep repeating the same thing every day, day in day out, again and again, without maintaining quality. Yeah, so you have something called the Dr. Deming's philosophy for continuous improvement. What does it say? It has 4 stages, which is the plan, do, check, and act. What do you mean by plan, do, check, and act? So plan is to set goals and plans. Even in your daily life, when you wake up, you set some goals and plans. Okay, for today, I want to achieve this. I want to do that. I want to be able to complete my first chapter for introduction for my final year project. I want to finish studying the first chapter for my manufacturing processes. Yeah, so you plan, you set goals and plans, and then you make sure that over the day, throughout the day, you implement and accomplish the plan. So if you said that you need to finish chapter 1 of manufacturing processes, then you sit down and you study for chapter 1 of manufacturing processes, right? And once you're done at night, you check, okay, you gather data to find out what happened. So you already planned that you need to study manufacturing processes chapter 1. You need to do your, say, your final year project. You need to complete a certain part. Okay, so you have planned out for the day. So when you go back and check and see whether you've achieved your target, okay, if you've planned 10 things, have you achieved those 10 things? Or you've planned 3 things, have you achieved that 3 things? If you achieved that 3 things, very good, excellent. But if you have not achieved it, then you need to find out what happened. Were you like wasting time on unnecessary things? Were you distracted over something? So then you act. So if you're distracted over something, then the next day, make sure that those distractions are removed from your mind and from your way. You make sure that you don't get distracted by those kind of things, and you again set your goals for the next day. So same thing happens in the industry. Yeah, you plan, do, check, and act. So they normally in industries, they plan their activities, they set goals and plans, and then they actually implement. Okay, say it's for a month production, their target is they need to achieve 5,000 products. So they implement and accomplish the plan. So they have set their goals, the number of workers, the production run, the number of working hours, everything has been set and in place. They start the production. So they go on and on and on, and at the point of 1 month, did they achieve it? So did they accomplish their mission? So they check or they gather data to find out what happened. If they had already achieved 5,000 products, great. But if they did not achieve, they need to know what happened. Was there a problem with the machinery? How did the machinery crash? Why did it crash? Wasn't it serviced? Or were the workers taking their own sweet time, negligent? They're not focusing. So what actually went wrong that you could not achieve your 5,000 product target? Lastly, you act. After analysis of results, you act to improve the process. So based on this philosophy of continuous improvement, it involves several steps. In order to make sure that everything is well aligned, you need to have planning and education. So each department provides updates of the quality policy to the highest management. So make sure that this quality implementation is successful. So in a company, there's several different departments that operate simultaneously to ensure the success of that company. Yeah, So every day, each and every department has to be reporting to the higher management on their progress and how are they or what are their plans in achieving that ISO certification. Okay, so in terms of customer and supplier analysis, the organization should have an understanding of the customer and supplier demands. That means to make sure that each and every customer demands are met. What are the procedures? They need to outline procedures to meet the customer requirement that is under the ISO certification, right? So process flow analysis. So when you conduct production, if you remember, I told you there's a process flow that you need to follow, right? That means from raw material, what happens next, so it's your duty as the team leader or the production manager and all your subordinates to monitor. If you already have a standard process flow analysis, you can monitor to see which process flow or which flow can be removed, or maybe which function can be removed, or what can be incorporated to make sure a much smoother flow of that process analysis until you get your final product. And how do you make sure that you minimize scrap and you maximize production? Yeah, so that also needs to undergo an ISO certification or ISO process analysis. So you need to step by step outline the process flow analysis. And lastly is your problem analysis and improvement. So at the end, you must make sure that you have a mechanism to monitor what went wrong. Okay, despite having maintained quality in all the levels and stages of reporting, and you still have some rejects, or if something went wrong, you need to have a standard operating procedure of how do you handle these problems, and also how do you suggest solutions or improvement to these problems. So this is your Dr. Deming's theory, yeah? Plan, do, check, and act. Okay, so when a process variation occurs, what could possibly cause a variation? Yeah, so a variation is the inability to perform a task consistently according to the customer specifications or demands. So what are the sources of variation? Process variability, the inability of the manufacturing to produce identical parts. So why is it unable to produce identical parts? Is there a problem with the machine? Is there a problem with the workers who are handling the machine? So product degradation over its life cycle. You cannot do anything about this because product degradation occurs in any product. Yeah, that's when you have to make sure that your product is in par and in the market, while in the market. So for example, you take a handphone. The moment the handphone is out, you find people queuing out of shopping centers and the outlets, retail outlets that actually are producing or are actually selling these handphones here, right? The latest model, for example, Samsung comes up with the latest model. So people are rushing to get hold of the model because it may have, or it will come with good features or some additional features that's not present in the current handphones. So the trend will go on for 1, 2, 3 months maybe, and then slowly the competitor, okay, may come up with a new model. Then people will rush there to actually check out that new model. So eventually your current model in Samsung would start to see a decline. Yeah, so before it hits the rock bottom, Samsung needs to come up with a new model in order to attract back the customers. So this is an ongoing process. Yeah, product degradation occurs, so you do not let that degradation hit the rock bottom of your production. Yeah, so before it hits the rock bottom, you come up with a new model and then it will pick up again. So this is an ongoing process over and over again. External factors, okay, say initially you're buying your raw materials from a company in Australia, and suddenly the material becomes scarce, and now you need to purchase the material from another company elsewhere. The quality or the finishing of the material may not be the same. So that is called external factors of degradation. Manufacturing process degradation. So your employees may change. Yeah, so you're replacing new employees to run the production. The production style may be different, or you're replacing machines. So the machine functionality may be different, and this may cause a product or process variation. Okay, so causes of dimension variation. Dimension variation can be either by chance or random causes. For example, equipment accuracy. The equipment has not been calibrated according to the timeline. Weather, material properties, and this cannot be controlled. Yeah. Weather, sometimes if it's too cold, material shrinkage occurs, okay, more than ever. So even a very slight change in dimension can affect the quality of your product. Then you have something else called assignable or special causes. Worn out equipment, improper tooling, material defect. All these causes can be eliminated. Material defect can be detected before you use the material. You need to check your material before you use it. Using the wrong tools, it's a negligence problem. It's not a manufacturing problem. Yeah. Worn out equipment, if you know your equipment is worn out, you should replace it before it reaches its deadline, right? So there are causes that can be controlled and causes that cannot be controlled. Yeah. So all this happens during a manufacturing process production. So again, how do you monitor variations? In this current technology, we have automation to monitor it. However, if you're going to do it manually, you have something called a statistical process control, SPC, to monitor and control the variation. SPC is systematic method of tracking, predicting, and minimizing process variation. And you obviously have control charts. Yeah? I just spoke about the control charts. Yeah, so you have control charts to monitor your variation. So here defects. Yeah, the moment the defect goes out of the upper control limit or the lower control limit, or you find an unstable trend, then you have to stop production and monitor what is going wrong or what is causing this variation. Correct it, and then you restart your process again. So that's all for today. Thank you very much.